let's take a look at another pair of properties. The first is the power of a product rule. In this case, if you take a product, so A times B, and apply a power to that product, this power is going to apply to all factors within the product itself. So it applies to the factor A, it also applies to the factor B. Okay. Again, this is one of the more common ones that you'll see. So if you have something like this, that power of 2 is going to apply to every factor inside the grouping symbol. So we have a numerical factor. We also have a factor of base x and base y. So we're going to take 5 and square it, take x and square it, take y and square it, and then you just simplify what you have. So 5 squared, x squared, and y squared will stay as they are. Okay, the same holds true for a quotient. If you apply a power to a quotient, that power is going to apply to all factors of the numerator and all factors of the denominator. Okay, so if this is the number that we're looking at, this power of 3 applies to every individual base, whether it's numerator or denominator. So it applies to the 5, applies to the x, applies to the y, and then again simplifying 125x cubed over y cubed would be the simplest form when you evaluate it. All right, if we take a look at these values here. Okay, 3 to the 4th. Again, this is one of those cases where it's not a common power that you should be familiar with. However, you should be able to create the solution pretty easily. If you kind of build back from what we've already talked about, to get a power of 4, we could think of this as 3 to the 2 plus 2, which is 3 squared times 3 squared, same base, add the powers. And what is 3 squared? 9. 9 times 9 is 81. So you should be able to create that even if you don't have a calculator. You could also just multiply it by hand and be pretty safe. And what about b? Is b going to be 81 or negative 81? Does the power of 4 apply to the base 3 or to the negative and the 3? Just the 3. So negative 81 is your solution. What about c? Now the base 4 applies to the whole thing, negative 3, so it's a positive 81. And then in d, you can think of this a couple different ways. Easiest thing to do is, because you're dealing with the negative power, just invert your fraction. So our fraction is 1/3. We can invert it, 3 over 1, or just 3 to the positive 4 is the easiest way to look at that, and then evaluate it. You get the 81. In the second line, this power of 0 applies to the entire quantity 5t, so what's that overall value going to be? Just a positive 1. Here our power of negative 1 is going to take our whole base of 5t and move it to the denominator. Take it to the power of 1. Please don't ever write the power of 1, just leave it as it is. It doesn't add anything to the expression, so leave it out. In g, the power of 0 applies to the t or the 5t? Just to the t. So t to the 0 is 1. 1 times 5 gives us 5. And then finally, just a reminder that any unwritten power is a power of 1. So t to the 1st just tells us what we have. We have 1 t on that.